In the last lecture, we have compared recursion and iteration. And we saw that in many cases, iteration performs better than recursion in terms of time and space complexity. But there are situations where recursion is preferable instead of iteration. Now let's examine the situation where we should use recursion and when we should avoid it. As we discussed in previous lecture, the recursion is always used if we can easily break a problem into similar subproblems. So in such cases, we should always use recursion. Now the next point is that we should be aware of that whenever we use recursion, it brings with itself extra overhead. As a programmer, we might not be aware of it, but the system manages internally. So there might be time problems as well as space problems. So if you think that system will handle it without any problem, then go for recursion. This means that recursive method that we are developing will run on supercomputers. But there might be a situation we cannot compromise either with time or space. Then in those cases, we need to avoid recursion. For example, if you are developing a mobile application which should run on low memory devices as well, so in this case, recursion is not advisable. Similarly, if you are developing an algorithm for critical system which must be very fast, like the airbag system in the car, where fraction of second matters, you must avoid using recursion in these kinds of application. The next point here is that there might be a situation where we need a quick solution. Instead of thinking efficiency of our algorithm, we develop solutions using recursion. As we saw in our previous lecture, writing code using recursion is much easier. For instance, solving mathematical problems like factorial or Fibonacci, we can use recursion as an easy solution. So in the next lecture, we will see how to implement recursion methods for factorial and Fibonacci numbers. So recursion adds clarity and reduces the time needed to write and debug code. If you know your input into a function is going to be a small, recursion is certainly a good choice. If you want to declutter your code and your input is sufficiently large, and if you want to sacrifice speed and memory for the sake of clarity, then we can use recursion. The next point is that recursion is very useful when traversing the tree. Recursion is better at tree traversal. This one is a little more advanced. An extremely simplified version of what this means is a tree is a collection of objects that are linked to one another. Imagine leaves on a tree connected by a branch that are in turn connected into other branch all the way to the roots. Here you can see a sample tree data structure. Even though we are going to discuss this in detail in tree section, I'm just giving you a simple example here because recursion in a tree traversal is very efficient. One of the more efficient ways to traverse this tree when looking at a specific leaf is by recursively following a single branch until the end of that branch till you find the value that you are looking for. For example, in this case, if we start from here 15, we need to go all down till 1. So in this case, our recursion function will be very efficient. There are different types of traversal of trees, which we will discuss in tree section. But here you just need to know that recursion is very beneficial when you use pre-ordered traversal, where we recursively following a single branch until the end of the branch to find the value that you are looking for. Here we see that pre-ordered tree traversal works like this. It starts from 15, then it goes to 9, then it goes to 3, then it goes to 1. We see that this branch is finished here at 1. Then it goes to 4. Then again it goes back to this side of 9, which is 12. Then again it goes here at the other side of 15, which is 23. From 23, it goes to 17. From 17, it goes to other side of 23, which is 28. We will discuss this pre-ordered traversal in tree section. Here I just want to show you that in this case, recursion is very beneficial. Finally, when you use memoization inside function, the time complexity can be reduced. But this means that if you memoize the result by saving the value of each calculation for further use in the recursive call, you can in fact reduce the time complexity. This is also advanced topic and I don't want to confuse you here. So we will talk about this topic in dynamic programming section. Let's continue to see in which situations we cannot use recursion. So here we can easily say that when you face the reverse case of these cases we mentioned here, then we cannot use recursion. So if we cannot divide our problem into similar subproblems, this means that recursion cannot be used. And if time and space complexity matters for us, then recursion is not advisable. Recursion use more memory because the function has to add to the stack with each recursive call and keeps value there until the call is finished. The memory allocation is greater than that of any iteration function. If we use embedded memory, for example, an application that takes more memory in phone is not efficient. And the next point is recursion can be slow if not implemented correctly. It can be much slower than iteration. It's actually pretty difficult to write recursive function where the speed and memory will be less than that of iteration function, completing the same task. The reason that recursion is slow is that it requires the allocation of new stack frame. So that's all for this lecture. Hopefully you understand when we can use recursion and when we need to avoid it. See you in the next session. Keep learning, keep smiling.